Well, good evening, everybody, and welcome to tonight's LPLS talk. My name is Eric Blair. I'm president of the Society, and I'd like to extend a very warm welcome to all of you, members and visitors alike, and in particular, a very warm welcome to our two speakers tonight, David Hart and Shirley-Anne Sherriff. Rachel's going to introduce David and Shirley-Anne in a moment, but just a few things to say in introduction. I mean, we're very into wool in Leeds, and this topic is really great for us. And we often refer to wool in many guises, and so we've been interested in wool through the structure of keratin, and the work of William Asbury is something that we've followed and promoted, and funded books and so on and so forth. And we've also had a number of talks about textiles, dyes, and pigments, and so on. And so, we've been kind of going around the molecular and chemical aspects around wool and the scientific aspects of the wool industry. So it's really great that we can kind of follow this one through to the sort of global perspective and the battle for textiles that David and Shirley-Anne have entitled this talk. So once again, thank you, David and Shirley-Anne. I'll hand over to Rachel, who can introduce you in more detail.
Thank you, Eric. And yes, indeed, welcome, my old friends, David and Shirley-Anne. David's a Cambridge geography graduate, and Shirley-Anne's first qualification was from the University of Cape Town in her native South Africa. And they both worked at ICI and spent some time in Germany. And they've had this global textile consultancy run from Harrogate for about 3 decades now. They have traveled quite widely and have clients internationally, as well as attending conferences around the world. But they have actually found it very easy to adapt to entirely working from home, as that has been their main office all this time. Their constant need to stay on top of the global and specific business trends in textiles means they've amassed a wealth of understanding in this vast and complex industry. And they've developed the skills required to explain what's going on and to consider what could and should be happening next. So over to you, Shirley-Anne and David. Thank you very much.
Okay, thank you, Rachel. So, as you said, we spent our entire working lives in the fibre and textile industry, the first half in large chemical companies making and selling synthetic fibres, and then latterly in our own consultancy business. The paper we prepared for you,
there a minute ago. Sorry, when the technology doesn't help you, just give us a sec.
Okay, which was on you, though?
Yeah.
The paper we prepared for you is set out as follows. I'm going to spend about 10 minutes at the beginning giving you what I think was a new perspective on the textile industry. There's this horrible tendency to regard it as a little old granny in the corner with a spinning wheel. Something like that is a huge modern industry growing very, very rapidly. So I'm going to talk through some of the changes in the actual textile processes. In sections 2, 3, and 4, pin down some of the specific numerics of the industry, how fast it is growing, astoundingly fast. Number 3, what that means in terms of the fiber types we're using, which are changing quite radically. Then number 4, the drivers of textile supply chain location, this battle for global textile activity, trying to wrench activity into your geographic region for all the economic benefit that brings. I'll then hand over to Shirley-Anne, who will address the whole environmental sustainability issue of what the textile industry is doing in relation to those challenges. As I said in my first comment, we tend to think of textiles as this quaint little industry, but I can make a very good case to say it's the largest global manufacturing chain. If you look not purely at the textile sector, but the value of the finished products we make, so apparel, household textiles, industrial textiles, I can come up with a figure of $4 trillion per year. By contrast, the auto industry, $2.8 trillion, aircraft industry, 0.6, shipbuilding, 0.15. So my proposition is textiles is the largest manufacturing industry on the face of the planet. It is high growth and it's technically inventive. I'm often offended when I talk to people whose perspective of textiles is buying their vest or pair of socks in Marks and Spencer. And I'd like to start with just one quick example of a textile application that was quite astoundingly successful technically. NASA had a 10-year program, their Perseverance mission to Mars in 2021, cost them $2.7 billion. The module containing all that kit hit the Martian atmosphere at 20,000 kilometers per hour, i.e. 16 times the speed of sound. They actually deployed a parachute at that speed. I mean, spectacular, astounding. That parachute deployed in the thin Martian atmosphere, clawed at that atmosphere and slowed down that module by 99% in a 4-minute period. The fabric it was made from was a combination of polyester, nylon, and aramid called Kevlar, and each square meter of that fabric was carrying something like $270 million of investment. If you want to know where that spectacular textile was made, if you potter down the M5 to the little town of Tiverton, on the outskirts of Tiverton, you'll find John Heathcote's, who make the best parachutes in the world, and they were the people who delivered that $2.7 billion of investment safely to the surface of Mars. Let me now just talk you through some of the key textile processes just to show you how much they've changed. Top left here, an amateur, that's Queen Victoria with her little spindle, single-handedly trying to put the Indian textile industry out of business. Middle at the top there is mule spinning, the original mechanical spinning, these huge frames moving backwards and forwards. When I first started selling staple fiber in the 1970s, there was actually still a mule spinner operating in Lancashire, making very fine specialty yarns. But the industry I really entered into, shown primarily at the bottom here, this is classic ring spinning. And that system got up to 12,000 RPM. So from the beginning of time up to about the mid-1970s, we got up to 12,000 RPM. We then introduced a new system which used an air vortex to crush the fibers into a yarn shape. So no mechanical moving parts, simply an air vortex. And as we sit here now, they got up to 150,000 RPM. So spectacular increase in spinning speed. This is a modern air jet spinning system. You might say, where are all the people? The answer is there aren't any. It's roboticized. So these robots here whiz up and down these frames. They take off the full packages. They piece together broken threads. It's heavily roboticized. If we look then more at the industry that Shirley and I come from, when we extrude a synthetic product, basically we squirt a molten polymer through a metal disc with holes in it called a spinneret. And you get these lines of molten polymer coming out. To make a staple fiber, i.e. like cotton, we then cut them and we come up with this sort of product here. We say to the industry, okay, here's our version of cotton. And then somebody said, well, actually what you're doing, you're actually making a filament yarn, you're cutting it up, and then you're paying somebody else to twist it again and put it back into a spun yarn format. Why not just keep it as a filament yarn? And that's what we see on the center right here. These are filament yarn packages we call cheeses for obvious reasons. At the bottom here, again, robotics, doffing from the machine these series of filament yarn packages. And the big picture on the right here is the sort of operation where Shirley and I spent half our career This is a filament yarn extrusion plant. It's about 3 stories high. Top story is where we actually push the polymer through into the spinneret. This middle area here, again, about 3 or 4 meters high, is middle section. If you open these glass doors, you see the yarn cooling as it comes down, hurtling down at high speed. Then at the bottom here is where it's all being wound up. We wind nylon yarn at 3,000 meters per minute. We wind polyester yarn at 5,000 meters a minute, 5 kilometers per minute. There is no spun yarn system that can come anywhere near that, which is why if you can use a filament yarn, you do so. And synthetic filament yarn now comprise 50% of all global fiber usage. If we move down from that yarn level and we look at the weaving looms, again, Rachel did a speech recently talking about flying shuttles, first mechanical loom. This picture bottom left is roughly the sort of weaving shed I encountered when I first entered the industry. 36-inch wide looms, hurling a heavy shuttle, wood and metal, clunk, clunk, clunk from side to side. Stand in front of these looms and you hear this whack, whack, whack of the shuttle being hurled backwards and forwards. We don't do that now. Modern looms are air jet or water jet. Imagine filling your mouth with air and then puffing a thread of yarn across the width of the loom, or getting your mouth full of water, puffing the water across. That's how we actually insert weft on modern looms, air jet or water jet. The looms are now 60 inches wide rather than 36. And these things, you don't hear clack, 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 because there's no heavy shuttle. What you hear instead is there's a reed, which is basically like your hair comb, pushing forward to compact the weft thread into the body of the fabric. And you hear this continuous drumming noise. This reed is coming forward so rapidly. It's doing 1,000 to 1,500 weft threads per minute. Back in these looms, you used to pray for the fabric to come off the loom. It was moving so slowly. These modern looms, you can actually see the fabric being wound off. And these are making 3,500 meters of fabric per week. The second major sector is knitting. See a watch there, please. And you got here at the top left, the knitters in Paris, not diverted from their knitting by the heads rolling. Bottom left here, the first mechanical knitting, which was William Lee, got fed up with his lady love, spending too much time knitting. So he invented the first mechanical machine, turned to her and said, okay, you've now got no excuses. Somewhere in the middle here, about 1920s, 30s, you can see the machines have got bigger, but they're still winding this tube off the bottom. But this is what a modern circular knitting machine looks like. There's thousands and thousands of needles in the middle here in a circular pattern, and again, winding the fabric very, very rapidly off the knitting machine. The main yarn comes from these creels at the side. These funny little donut packages on the main body of the machine are actually spandex, so lycra. So this machine is knitting a stretch fabric. The final bit of textile technology I wanted to wave in front of you actually originated from the paper industry. And what we do with this non-woven fabric technology, we take the fabric from the car, the full width of fabric, this loose, uncompacted fiber, and we stabilize it. We do that either with resin bonding, which is essentially gluing it together, or with things like heat bonding with a hot calendar or an oven. These things, you see these huge rolls, make 50 to 100 meters of fabric per minute. So 1 week's production on that high-speed loom I showed you, 3,500 meters, these machines make in 35 minutes. You may say, I wouldn't touch that papery stuff with the barge pole. Too late, it's already omnipresent in your lives. Diapers, hygiene fabrics, medical textiles, the wipes in your kitchen, the linings in your formal apparel, in your duvets and your cushions. That is not loose fiber, it's actually a three-dimensional stabilized fabric. Geotextiles, roads, railways, canals, in your car, filtration, insulation. So 12 to 15% of total global textile manufacture is already non-woven, and this sector is advancing faster than the traditional textile systems. That was simply to say, forget about, your pair of socks. This is a space age modern industry that's developing very, very rapidly. Let's look at how fast it's developing. In the year 1990, down on the left here, the entire world, every country, every end use, apparel, household, textile, industrial, used 38 million tons of fiber. By 2010, we'd more than doubled that to 78 million tons of fiber. By the current year, 2022, we're passing through somewhere near 100 million tons. But the most astounding statistic is that in the current decade, we will add more textile demand than the entire global total in 1990. So in one decade, 2020 to 2030, we're adding more demand than the entire global industry in 1990. You could be either impressed or appalled by that number. Why is that happening? The lesser reason is world population growth. 6 million, 7.5 million, heading for about 8.3 billion, rather, by 2030. Most of the global regions have stabilized their population if you exclude immigration, but two regions, sub-Saharan Africa and the Indian subcontinent, are essentially driving global population growth. More people means more textile demand. But the major reason is all of us each year are consuming more textiles. We look at these regions here, North America, Western Europe, China, coming right the way through to India, Africa, Middle East. The Americans, every man, woman, and child, every single year uses 36 kilos of textiles. So 3 big rucksacks for every man, woman, and child. Europe, 23 kilos per capita, okay, in all the end uses, not just your underwear from Marks and Spencer, but the textiles we use in building roads, building housing, the airbags and the tires in your car. We use 23 kilos per capita. If we come across here to India and Africa, Middle East, these huge populations use only 6 kilos per capita. But those guys all say, we want what you've got. To convert India from 6 to 23 kilos per capita, you would need 20 million tons of additional fiber. So what's driving most of the growth in global fiber demand is simply every single region, every year, consuming more fiber. And that's a process that shows no sign of stopping. Let me look now at what that means in terms of the fibers that we use. Where do those fibers come from? And this chart shows us back to 1980, 30 million tons, hurtling up to about 138 million tons in 2030. We look first of all at this blue area at the bottom, that is cotton. Back in 1980, King cotton, it was called, was bigger than all the rest of the fibers combined. By about the mid-1990s, that crown had slipped. Cotton was the biggest single fiber, but no longer larger than the rest of the fiber industry. Cotton's tried very, very hard to grow new genetically modified variants, more pesticides, more fertilizers, but it's stuck somewhere around this 23, 24, 25 million ton mark. And unless you want to stop growing food crops and grow cotton instead, there's no realistic prospect of cotton getting a lot bigger. It's being helped out by this brown area, cellulosics, so viscose fiber. Saw down your tree, mash it up, get the cellulose and extrude that as fiber. So viscose fiber, a cellulosic pseudo-cotton fiber. At the top here, we have the pink, which is polypropylene, doing very well, used very substantially in non-woven industry, medical textiles, disposable textiles. And the blue just up there is nylon, which we think of as being a big fiber, but actually nylon is expensive and quite exclusive as a fiber. But the real winner is this green area in the middle, which is polyester, polyester, polyester. The staple version, where we've cut it into a fiber like cotton, is shown in the dark green. But the filament area clearly is more successful for all the economic reasons I explained and is winning the battle. Polyester is now more than 50% of the entire global fiber and textile industry. And by 2030, it will be knocking on the door of that 60% number. If I show you the same statistics as percentage, you can see cotton here falling steadily as a percentage. And in the introduction, wonderful wool was mentioned. Is poor old wool. Wool is less than 1% of global all fibers consumption and is increasingly an expensive minority specialist fiber. But you can see again this huge wedge of polyester opening up in the middle. Why is polyester so successful? If you look on the left here, we've shown you some of the key categories for apparel, household, and industrial. And these blocks are roughly proportionate to their size in total global textile consumption. If we look at the segments where cotton has an offer, clearly it's not too bad in the apparel sector. It struggles a bit in household textiles, and it's virtually not present in industrial. We look at fabulous polyester. Polyester has an offer for almost every single sector of the global textile industry. You can make polyester into filament, into staple, monofilament, microfilament, high tenacity for industrials, lower tenacity, silk-like fabrics. You could do anything with polyester. It's available from a huge range of sources. It's dirt cheap. It's omnipresent. That is why polyester is the global winner to date and looks like following up with even more growth. Let me drive on then to my final section. What drives textile supply chain location? We've talked of a battle for textiles, and believe me, the last 40 to 50 years, countries have fought viciously for access to textile manufacture, a lot of jobs, a lot of cash value. Let me explain to you the key rules of that game, and there are two. If we look at the three key levels of the industry, the yarn level, the fabric level, and the garment level, if you go into a synthetic yarn factory and you look around, you'll see the odd head bobbing around in the distance. But essentially, those things are huge machines roaring away with human beings really very limited, a lot of robotics there, just one or two people. If you go into a modern weaving shed, actually, you don't see that many people either. One man operates 10 looms, 20 looms if it's a simple fabric. So you see the odd head bobbing around in the distance. But it's only when you get to this garment level that you begin to see what most people think of as traditional textile labor intensiveness. So rule one of the game is as you go down the supply chain, the labor intensity increases, and therefore the importance of labor cost increases. The reciprocal is as you go back up the chain, the capital intensity increases. Theoretically, the minimum capital cost at that garment level is a needle. In fact, most of what they're using are very, very modern, high-speed sewing machines, $10,000, $12,000 per machine. You come back up to the fabric level, looms, $35,000, $50,000, up to $100,000, cost you £1 million to put in a small weaving shed. Come up to the yarn level, one single line, $5 to $10 million. You want to put in a real plant, you've got to have, 10, 15 of those machines, you're into $100 million. So the industry is driven by those two rules. You can retain a yarn industry, synthetic yarn industry in a high labor cost area because it's capital intensive. You're not too bothered about labor cost. But the garment level essentially is determined by cheap labor cost, which is what the industry charges around the world pursuing. So what we've seen in the post-war period was in the 40s and 60s, Europe, USA, perfectly healthy textile supply chain. By the 1950s through to the 1970s, Japan, recovering from the war, determined to succeed, a lot of new investment, diligent, intelligent workforce, was beginning to take a commanding share of global textile manufacture. As Japan became more successful, wage rates went up, people went into the electronics industry, higher value activity, And the textile industry slowly moved offshore into Korea, Taiwan, Hong Kong, that we then call the Asian tigers. And they scooped up a large part of the global industry of the 1980s, 1990s. But again, as they became more successful, their wage rates went up. And by year 2000, China was busy welcoming, first of all, the apparel industry into the Greater China, followed by textiles and then by fiber manufacture. Theoretically, I mean, if you go to the coastal provinces of China, their wage rates now are not a lot different. In fact, exceed minimum wage rates in the UK. So labor in China, the coastal provinces is where a lot of this industry is currently located, is not actually that competitive. The theory is therefore that as we look ahead, that industry should move into the Indian subcontinent, down into Southeast Asia, particularly Vietnam, Cambodia, maybe Indonesia, and maybe into parts of Africa if they could stabilize their political situation. China, however, has made it very clear that they're not prepared to let loose, release one single dollar of activity. They want it all. And they're doing a number of things. Firstly, they're investing in the most modern, high productivity equipment. If your wage rate goes up 10% and your machine runs 15% faster, you've actually reduced your unit labor cost. They're also focusing on higher value-added textiles. For example, the sort of industrial textile I mentioned with that parachute example. If you've got high-cost labor, make higher value textiles. Where they have to go abroad, they themselves are putting plants into Vietnam, Pakistan, Bangladesh, some of that tied up with some of the strategic geopolitical aspirations that China has in the Asian region in particular. And within China, as you move from the coastal provinces there and you go westward, basically labor costs reduce as you go westward. And clearly the final example is Xinjiang province, where there are strong accusations that essentially free slave labor is being used in the cotton industry. This is a picture of where textile mill production took place in 1990. So not consumer demand, but where textiles are manufactured. And you can see that's a fairly nicely balanced global industry. China had 18% of global activity, more or less pro rata with its population. By 2020, Europe and the Americas have said, actually, well, you know, we're a sophisticated, service-oriented economy, don't need that funny manufacturing stuff. Let China do it, dirt cheap, keep our inflation rate down, and we have other things, better things to do. China said, thank you very much. They're now 55% of the global textile manufacture. Southeast Asia is beginning to do better, but China is the absolute total commanding presence. Let me now just summarize some of the themes that I've offered you there. Firstly, forget your traditional granny in the corner image of textiles. It is not like that. It is a huge, huge global industry, arguably the largest manufacturing industry on earth. The rate of growth and the rate of technology advance is logarithmic. It is not a straight line, you know, it's incredible. Labor cost remains a defining factor, but we could in the next 10 years enter a huge increase in robotics in the industry. Could actually have robots sewing garments, and that could heavily dilute the driver of labor cost. China, dominant feature of the global textile industry, but COVID and supply chain problems from China, geopolitics, will they invade Taiwan, could reconfigure some elements and could place greater value on regional supply chains closer to the consumer. I wrote this little afterthought actually prior to Russia's invasion of Ukraine, but I would say it actually underlines these final comments. My proposition is human populations have three key requirements: ability to feed ourselves, let's be nice to the farmers; ability to meet our energy needs, if you want your lights to stay on; and finally, the ability to clothe ourselves. And in an increasingly uncertain geopolitical environment, all three of those factors deserve strategic planning and attention. let me now hand over to Shirley-Anne, who's going to talk to you about the sustainability challenges of the industry.
Sorry, so I'll just swap over here. Thanks, David. Sustainability, such a large topic and a very short amount of time to do it some justice. It will come obviously as no surprise, having appreciated the size of this industry, that it must have a very, very large environmental footprint. And that stretches across a whole range of topics, from carbon footprint, greenhouse gas emissions. Some people say as high as 8% of global greenhouse gas emissions come from this industry. Other studies say 2%. Take your pick. It's quite difficult to measure these kind of things. Its use of water, growing of cotton, but also the dyeing and finishing of textiles, which is very important. Degradation of land, things like unacceptable labor practices that David made some mention of. Also pollution, particularly of water, and waste. What happens to all these textiles at their end of life? So I'm not going to be able to cover all those topics, but I'm going to just start with a few words on the last two. So I'm going to start with end of life. What happens when we as consumers get rid of garments? Now, data is quite sparse for textile waste, but the estimate is that in the so-called richer markets, it's probably something like 5 to 6% of municipal waste. If you look on the left of the graph, you'll see a World Bank analysis of global waste composition, and we don't even feature. So food, paper, plastics is about 3/4. I would also add that, in fact, open dumping, not even in municipal waste, is the main method of textile disposal. So this doesn't capture the whole picture, but we'll just stick with municipal solid waste because we can actually get some figures for that. And 5 to 6% doesn't look too bad. But if you actually look at what that means in numbers, this data from the Environmental Protection Agency in the US shows that in 2019, Americans got rid of 17 million tons of textile waste. A comparable figure for the EU projected to reach 16 million tons by 2025. So David spoke of an industry of around 100 million tons. Well, a third of that is being thrown away just in US and EU as two regions, which I think is a disgrace, actually. What's happening to it? Well, again, you'll see from that little table there that the vast majority, something like 85%, either goes into landfill or is burnt. And a dire 15% finds its way into some sort of recycling. What does that actually mean? Well, we can't always agree from region to region on what recycling is, but it includes things like the rewear and reuse of garments. So you think of the charity shops, but you also think of a lot of our used garments, which we're sending, for instance, to Africa, and Greenpeace has just done an expose recently saying that this is just actually a cover-up for us sending our waste. The garments going down there aren't reusable at all. Otherwise, it's being downcycled and cut up into things like wipes and insulation. But everybody seems to more or less agree that actual textile to textile recycling, taking an old textile, reworking it and coming up with a new garment is less than 1% of what we dump every year. As I said, rather a disgrace. Talking a moment then about pollution, water pollution. You don't have to watch David Attenborough's documentaries to have seen, I'm sure, many pictures of the awful soup of microplastics that is in our oceans, on our coastlines, turning up in all sorts of marine species, but now even turning up in carrots and potatoes and human lung tissue. And the implications both for all those species and the habitats is poorly understood, but I think everybody agrees this is a big problem. Now, where do we fit in? Where do textiles and clothing fit in? Microfibers found in those microplastics. Well, again, pick your research study, but here's one shown from 2017, which suggested that clothing and textiles make up about 35% of that microplastic contamination. Another one from Eunomia that looked at a slice of the ocean floor And there they discovered that about 190,000 tons of almost 1 million was textile waste, basically. So about 20% of primary microplastics. Whether 20 or 35%, it's still a large number. All fibers shed, but polyester, as you've seen quite clearly, is the largest act in town and tends to be the largest part of this. And also, of course, natural fibers, cellulosics, will degrade quicker. But on the more positive side, there is a lot of work going on to look at research into how we can more carefully select yarns and fabrics to mitigate this release. There's a body called the Microfiber Consortium, which is working towards global standards that retailers and others can adhere to in terms of trying to address this problem. So it is awful, but there is work going on to address it. Now, a lot of people in the time we've been in this industry say to you, well, what's the good fiber? What should we all be wearing? Is it cotton? Is it wool? Is it, what's the one we should all be looking for? The answer is there are no good and bad fibers. There are good and bad ways of producing, processing, using, and disposing of them. And selecting three of the largest ones that David referred to, polyester, cotton, and viscose, I'm just going to briefly take you through a few pros and cons. So polyester, obviously, based on fossil fuels, which is good, and energy intensive of the process in terms of extraction from oil all the way through. And also these garments tend to hang around, garments or textile products made of polyester, because they're durable, they hang around at end of life. But on the positive side, it's an immensely efficient production chain. There's very little waste and there's very little pollution through that chain. And on the plus side, these garments are also very durable in use. And we all know about the fact that they wash and dry very easily. You don't need to iron them, etc. Cotton, well, there are quite a few things, I'm afraid, in the cons there, not least the competition for arable land, but also use of chemicals. Cotton has cleaned up its act enormously in the last decades, but it remains something like 2.5% of global arable land that are using about 16% of the pesticides and another 6% of fertilizers. And obviously that has led to some significant soil depletion. Also with global warming and cotton arguably being grown in parts of the world where it shouldn't be, it's heavily intensive on water for irrigation. Again, methods have improved enormously, but they are still not good. And as a process of taking natural products through from a crop through to fabric, you do lose quite a lot in that production chain. But on the positive side, there's some, as I said, really good work going on, not just on organic cotton, but also on things like the Better Cotton Initiative to reduce chemicals, water, better treatment of the supply chain. But those types of cotton today, together with organic, only represent about 15% of the production, but it is growing. It's a good durable fiber, and obviously at end of life will degrade faster than synthetics. Viscose, David mentioned, comes from cellulose in wood pulp, and the worst producers will destroy forests to get to that point. It also uses some rather hefty chemicals in its production process, so much so that the Chinese government at one point shut down vast swathes of the viscose industry because it had so polluted with effluent the waterways. One of the benefits of a totalitarian regime, they could actually do it. They actually put CEOs of companies in jail until these companies cleaned up their act. On the other side of the coin, some very, very responsible producers looking at closed loop production systems where you recover your chemicals and your water, and also using wood pulp from well-managed sources. So no goodies, no baddies, just pros and cons, good producers, bad producers. I'm going to share with you this life cycle analysis, which was done by the University of Delft and Utrecht in a joint project to look at a benchmarking study on different textiles. And it may surprise you to see there that cotton over on the left-hand side is the worst performing in terms of this study, certainly worse than polyester, which is its biggest rival. They came up with the concept of eco-costs, which put together things like carbon footprint, toxicity, material depletion, and so on. However, I would say, despite the results I'm showing you there, that LCAs can be biased. They are very often, they were actually financed by either the cotton lobby or the synthetics lobby. And of course, much depends on where you draw your boundaries, cradle to gate, cradle to grave, cradle to cradle, etc. So there's a whole science of LCAs, which some of you may be familiar with, which make this really quite a difficult area. But I'd like to leave you with this quote from the research institute Mistra in Sweden, which is doing a lot of good, I would say, neutral work in this area of looking at different product types. And their future fashion report said, and I'll quote, "Selecting the right fiber for the right application is key for optimizing the environmental performance of the whole product life cycle." So that's really what we need to be thinking about. So who's driving sustainability targets in our chain? It is quite clearly the big brands and retailers, the names you'd recognize, the Nikes and the Marks and Spencers and so on of this world. And when you talk to the supply chain, which we've spent our working lives doing, they complain that they have this barrage of requests coming at them for biodegradability or recycled content, or there must be no hazardous chemicals in the chain. And what are you as a supplier doing about your waste chain? And are you transparent? Can I see what you're doing? Because Greenpeace and all these guys are jumping all over me, etc., etc. Are you following the United Nations Sustainable Development Goals, and so on and so forth? But the feeling often is that underlying all of these discussions is the requirement in this highly competitive industry for always lower prices. And it's not just the apparel brands that you would know, but also industrial companies like the big car companies. And of course, we're in an environment now with some of the most profound shocks to our supply chains, COVID, Brexit, energy costs, war in Ukraine, etc. And I fear that requirement for lower cost will sometimes be trumping sustainability requirements when it should not be. Just before I leave the brand and retail environment, one of the most crucial things to making any progress at all is to have measurement and good, solid, and I would argue neutral science as well. If you don't know where you are, how can you set targets, and how can you monitor where you are on this sustainability journey, as they all talk about? I'd like to draw your attention to the Sustainable Apparel Coalition, which was an organization founded in 2010. And I've put some of the big brands there. That is a very small number of the big names who are part of this. They're said to represent something like, well, at least 25% of global apparel retail sales. So a very influential organization. And what they try to do is come up with a measurement tool to improve the environmental performance at all stages of the chain. And they rather amusingly have called it the Higg Index. And the reason for that is they said this attempt, to get outright competitors to work together with each other to come up with a system which is immensely complex and to look for solutions has proved to be almost as elusive as looking for that Higgs boson particle, which they found at CERN so many years ago. So that's why it's been called the Higg Index. And one thought is that out of this process of a common measurement system could perhaps ultimately come almost a traffic light system like we've seen applied to some foodstuffs, where as a consumer, we might be able to pick something up and know whether it's red, amber, or green. What should we be going to? Where can we make an environmentally more responsible choice? Which would be a really nice thing to have consumers complain about not really understanding what's going on. So let me just talk briefly then about a few environmental initiatives. Where are people in this chain trying to clean up their act and come and produce better products in environmental terms? The biggest and only world scale example in the fibers chain is the reuse of polyester soft drink bottles. You're all familiar with them. We all put them in our recycling, hopefully, every week. But the chain didn't start using these plastic bottles, which are 100% polyester, out of any great care for the planet. Originally, it came about because it was a cheap alternative to virgin raw materials, because they could just be taken, mechanically cut up, respun, and you could produce cheaper products out of it. What's happened now, of course, though, is all the big retail brands have gone for some very ambitious targets in this area. And I'm not going to read through all of those, but it includes the big sporting brands like Adidas and Nike, and also the big general retailers and fashion retailers. You look at Walmart, they're saying they have a goal to put 50% recycled content by 2025. Inditex, which is Zara, the fashion group, 100% of the polyester they want to be recycled by 2025. These are very, very ambitious targets. And the problem for the fibers industry is that if I put up there the same targets for Coke and PepsiCo, you would see equally ambitious targets. The packaging industry actually wants its own waste stream. And so there's a real battle royal going on now over getting your hands on this material. Quick look at where it's coming from. I would start off by saying that about 6 to 7 million tons of polyester fiber comes down this reused polyester bottle route. So that's about 10 to 15% of the polyester fibers used in the world every year. And what this graph shows is the percentage of bottles recovered in each region in 2019 and what it might look like in 2030 as the current market stands. And what you'll see is that in Asia, it's already pretty good and improving. And that's particularly East Asia, Japan, Taiwan, China, already doing a pretty good job of collecting polyester bottles, even if there's more to go at. By contrast, the USA is pretty dismal, and even by 2030 is not even expected to get to half of the bottles collected. Improved regulation and collection may improve those numbers, but still it's not looking very good. And finally, if you look at Europe, there's been a strong increase here driven by regulation, particularly the EU Single-Use Plastics Directive, but also some of the brand targets that I showed you on the previous page. So some good things happening, but a major struggle over getting hands on this waste stream by the different brands. Just like to say a few words to you on bio-based products. A lot of work done in the early part of the last decade on replacing fossil fuel feedstocks with bio-based materials. These tended to be modular fermentation tanks, a much smaller scale than the larger chemical plants, which can run to 1 million tons, based on extracting some form of glucose from crops. So potentially you get into the problem of the food versus raw material, food versus fuel. That's bedeviled the whole ethanol story. Here too, the same problem can apply. And if anything, I think the impetus is reducing somewhat in this area, also because sometimes the environmental footprint doesn't always stack up. What am I talking about there? I'm talking about raw materials for polyester. Monoethylene glycol, which is about 1/3 of the polyester molecule, that is available today in vast quantities, also used in things like antifreeze. But the other side of the polyester molecule, paraxylene through to terephthalic acid, more challenging to make and far less of that available. One thing to note, though, is that by putting bio-based raw materials into a product, it does not make it biodegradable by the end of life. So you have the same problem you would have if you had used virgin fossil fuels. Another product, perhaps some of you may have heard of, polytrimethylene terephthalate, PTT, again, 1/3 of the molecule bio-based, and it's found a particular home in the carpet industry. It's the development of DuPont's as a relatively more sustainable option, but struggle to make much headway outside of that area. And finally, and perhaps a bit closer to home, polylactic acid, PLA, which is made mainly from cornstarch, although people are hoping to get the technology working on biomass so that you don't have this food versus fuel issue, mainly in plastics and packaging, but you will find it in things like disposable wipes that you can buy in boots. And these products are compostable, but only under controlled conditions. So some initiatives happening, some niches being found in the market, but perhaps impetus reducing in this area. Closed loop, well, that's got to be the holy grail, really, to be able to take textiles our own weight and manufacture new products rather than take it from other industries. There are immense technical and logistical challenges around this, not least how you actually collect clothing in the West, for instance, and take it back out to Asia for recycling and remanufacture, as it were. I'm just going to show you a few of the technologies that have been around. Chemical recycling, and again, I apologize for the quality of this graphic, pioneered by Teijin in Japan a good 20 years ago in conjunction with Patagonia, the outdoor brand. And basically they shipped in empty container ships garments back to Japan, took it all apart, depolymerized, and made new garments out of it. Again, if you look at it under an LCA, you have to question whether this is environmentally the best way of doing things. Newer technologies come through. This is Born Again Technologies, a UK company who've looked at using solvents to not take polyester apart, but actually extract it as polymer from used clothing, but also quite helpfully to be able to extract cellulose from cotton, so that you can actually look at polycotton blends, which is a large part of what we actually use. And then the final example I give is from the company Carbios in France, who are using enzymes to depolymerize polyester. They claim they can get it back to monomer within hours. This plant is at a pilot stage, but has EU funding for something like a 50,000 ton plant. So just to remind you of some of the numbers, 50,000 tons here, 6 or 7 million tons of used polyester bottles, but a 55 million ton industry every year. So small steps, but not enough as we stand today. And finally, I'd say a couple of words on what I can't really call an initiative, but that is that the most environmentally friendly strategy for apparel is to wear garments for longer and wash them less. And it's no surprise that when the researchers took a garment and doubled the number of washes from 30 to 60 cycles, they halved the greenhouse gas emissions. So no surprises there. And there are some initiatives. I call your attention to this one, the Clothing Longevity Protocol, which has been promoted by WRAP, that some of you might be familiar with, was a government body here in the UK, now a climate action NGO. And they've been working on trying to create more rigorous development and testing standards to help the supply side create longer lasting garments. But of course, on the demand side, we really need to educate consumers about the impact of fast fashion. And I think there we've got a long way to go. Final point I'd make is that there are social implications to circularity. The garment industry is so important to emerging economies as an employer. If we were really to start using less, we would need to think about how to mitigate social impacts in those poorer parts of the world. But wouldn't that be a nice problem to have? So finally, I'm just going to look briefly at a few new consumption models emerging and ask the question, are we beginning to see a cultural shift beyond fast fashion, this endless consumption of new products? This first scheme here I've shown you took place in the H&M Group, the large fashion retailer in Sweden, which is where their home base is. And in October 2020, when they weren't quite in lockdown, Sweden was a lot more open than we were in that phase. They launched this in-store garment recycling machine in their flagship store in Stockholm, where you could go in as a consumer with your used garments, and in that great big machine there, they chop it up, make a new yarn, and create a new garment for you within 5 hours. Yes, a gimmick, you might say, small quantities, but I think quite an important psychological change for consumers going into a fast fashion store to think about how what happens to their stuff at end of life, how can it be prolonged? This is a really interesting area, garment rental and subscription services, which are growing enormously, where you can rent a garment for 3 days to 3 weeks. You can get services whereby they'll put a personal, a set of garments for you. You can rent branded garments. You can even lend your own. You can put your own wardrobe online for other people to borrow. You can pay per rental, or you pay £50 a month, and you can order 5 garments for a month, send them back and move on. Even the big retailers are involved in this now, including M&S, who will rent out their own goods. But I'd call your attention to some of the smaller independents. This one down here, Her Collective, was called by Forbes magazine the Airbnb of fashion. These are disruptors, I think, in their business models. They're very tech savvy. For the young generation, it's across all your devices. They're very good at logistics, getting the stuff to you quickly, getting it back and turned around. So I think this whole area of garment rental, which is catching on so rapidly with young consumers, is one to watch. Then there's the sale of second-hand that has generally been handled by charity shops, for instance, in the UK, but is now coming into all levels of the market. So just this past month, both Asda and an upmarket brand like Hugo Boss have announced that they will sell second-hand garments in store. Now, I see that as really quite a shift. I don't want to do down the charity shops and the sterling job they've done for years, but this could really professionalize the second-hand clothing market. They've got the money to market it to consumers, to place it in the right place. It could really encourage consumers to think about second-hand much, much more. And then there's the old make, do and mend, which we would all have grown up with our parents telling us we should be doing more of. And it's been going for quite a long time with outdoor brands and people like Barber who would repair or re-wax your garment. But here again now is being extended to fashion brands who are beginning, I think, to take on board that they cannot with one hand say they're becoming more sustainable and still have the fast fashion model going at such a lick. So those are quite positive messages, if you will, but I'm afraid I'm going to leave you with a less positive message. And I'm going to raise this garment company called Shein, who are the fastest growing fashion brand you've probably never heard of.
Yes.
They're a Chinese brand. They started 10, 12 years ago, hugely social media savvy, promoting on programs such as TikTok, which most of us, I don't think, even go near. But they've turned into the world's largest online-only fashion firm within that decade, with a turnover of $30 billion, which makes them bigger than Zara and H&M, the big fast fashion giants, and they've jumped already to 28% of US fast fashion retail in that time period. They add an estimated 6,000 new products to their website every year. It's a shocking 2 million products, every day, which is a shocking 2 million products in a year. And many concerns have been raised about them as a company, from the quality of their products to, have designs being plagiarized, toxic chemicals in garments, workers' rights, etc. But they continue to grow rapidly. So yes, I'm an internal optimist. Yes, I believe there's some very good things going on in our industry, but I've started with a message for the consumer about waste, and I'm finishing with a message about consumers who aren't thinking about their impact of their habits. And maybe there are not too many Shein users on the line this evening, but I do think it speaks to the need for a cultural shift about the way we consume products. And there's a lot more to do. We really just are at the start of it all. So on that note, I shall stop, and we've come in at just on the hour, or just under 55 minutes. And David and I are available for any questions that anybody would like to ask. I'll bring him back into picture again, take a sip of water, and any questions?
First of all, David and Shirley-Anne, thank you so much for a wonderful talk. So we're having a virtual round of applause here. So thank you for a great talk. So wide-ranging and raising a whole lot of issues, which I guess we may have been aware of some of them, but to see all of this brought together is just quite mind-boggling. Now, everybody, you can turn on your microphones now and say your questions, or you can write questions in the chat, and Rachel and I will keep an eye on the chat, and we can read your questions or invite you to say your questions. So I think we've got the first one from Sandra. I guess David and Shirley, you could probably see the chat as well.
I haven't opened it.
Let me just read it. Should we as consumers just try to just buy natural fibres as clothes? So
the answer is that's utterly impossible. Go to your car. Do you want cotton tire cord in the way you had about 1900? You have a puncture every 10 miles. Do you want a cotton airbag? Do you want a cotton safety belt? I mean, there are vast areas of the industry, as I've shown in one of the charts, where cotton, frankly, does not have an offer. If you go in your house, for example, I would bet any single person there I'd find more synthetic than cotton. Your carpets, the curtains you may think are cotton are actually polyester. So essentially, large parts of what we want textiles to do, cotton can't do, is number one. Number two is, if you wanted to rely purely on cotton, that as we described, cotton's 25% of global fibers activity, even if you could do everything, you would have to reduce to 25% of your current consumption the textiles you buy. So either chop back massively your consumption and sacrifice huge areas of industrial textile. It's frankly not a feasible proposition. And as Shirley-Anne's explained, I mean, there's nothing environmentally friendly about cotton. Cotton essentially has destroyed the soil. The soil is absolutely dead. There's no ecosystem there. The soil simply props the plant up while you use huge amounts of pesticide, fertilizer, water. It is quite an appalling system. And frankly, the idea that cotton is the answer, pretty little lambs frolicking around in green fields is utterly lunatic. It's not a feasible proposition.
thank you. We got a few questions about different sorts of fibres. Bamboo was one. Fungus, Kirsten Hall's asking about biomass from fungi, and you didn't cover wool. I guess wool is such a luxury item now. I guess wool is a niche fabric.
It is a niche fabric, but I think by the same token, I think the wool is doing some really good stuff. So particularly looking at, for instance, its use in active wear, textiles, and so on. Yeah. Wool is a wonderful fiber. If you think of a really beautiful tailored man's suit, you've even got the speciality fibers like cashmere, again, beautiful jumpers. But they are, as David says, the specialities, if you will, they're the icing on the cake. They're expensive fibers. You cannot clothe the world in them. I mean, we're lucky as consumers in the richer markets to be able to make some of these choices. But you're never going to, as David says, get wool to do all the things that polyester or nylon or even cotton can do. We are great wearers of natural fibers. This wasn't intended to be any knocking of natural fibers. I think I tried quite hard to make the message to say there's horses for courses. Somebody in the chat has spoken about sensitivity of skin, can't use synthetics. There's any number of reasons why people need, or either for health reasons or for other choices. But I think when you come to looking, for instance, at waste, cotton garments are not going to just degrade. You can't compost them currently. Most composting facilities won't accept garments at all. Yes, they will degrade in the environment in landfill quicker than synthetics, undoubtedly. But as David says, you've got to look at the end users we currently have, the performance expectations we have for them, and pick the right fiber. As far as fungi are concerned, there are all sorts of interesting bits of research going on banana and spider silk and all sorts of things. But these are very, very much currently niche players. I think the whole area of mycelia and how they perform, how they communicate between trees, how they control termites in the recent Attenborough documentaries. I mean, we're learning extraordinary things, I think.
And you come back to the hard challenge of how do you actually present the world with 100 million tons of competitively priced product? Unless you can do that, and frankly, under the current sort of system we have, these things will remain, tiny little eccentricities and interests. It's not mainstream activity.
Thank you.
A brief issue, actually, when somebody mentioned cotton soft on the skin. I used to run marathons and half marathons. And believe me, if you ran in a cotton garment that was sodden with perspiration, it's like having sandpaper abrading your entire body. There's a reason why most athletic gear is actually man-made fiber with wicking structures. And that is certainly in the athletics area. Man-made fibers do a far, far better job than cotton in those against the skin applications.
Yeah. So Peter Henderson, he may have gone now, but he's asking about the energy consumption of, of oil and gas for making polyester compared with, other provisions. I guess how.
Well, that was captured in the LCA there that I showed you. That comparative LCA had allowed for, because it pulled together their carbon footprint as well as toxicity to the environment, et cetera, and those LCAs, which were independently conducted by those universities on a 70 denier, which is quite a lightweight, like a shirt weight fabric, showed cotton to be worse. And very often it comes down to things like water, toxicity to the environment, etc. So when you measure them all up together, yes, carbon is an issue, but water is an enormous issue for us, particularly as the planet warms. So again, it's always about balance, and I would really encourage people to think neutrally about the science of it all, rather than, we all tend to have our own favorites, I think, when it comes to fibers and the things we like to wear. But certainly if you're looking at it as a global challenge, we've got to be fairly neutral and cautious in the science.
I think somebody's asking about IPCC and climate change. And what?
Yeah, I mean, I think everybody was really rather disappointed with COP26. When I say everybody, sorry, I can't speak for the industry. I was disappointed with COP and the kind of things that were decided. I think what you hear from the industries a lot is they would love to see more government regulation. I mentioned the Single-Use Plastics Directive from the EU, which has driven bottle collection. So many of these retailers and brands and manufacturers say, create a playing field, a level playing field for us. If we're going to go down this route and we're up against a Chinese brand like Shein, which is just buying from the lowest of the low in cost terms, we're not going to survive because consumers don't care enough, is what we've seen. So, I think we would certainly as an industry like to see more regulation, more rules that people can apply to. The Sustainable Apparel Coalition is trying to do that as an industry initiative. Will the recent reports make people act quicker? Well, I hope so, because I think the risk of getting it wrong is becoming clearer and clearer, and big finance houses are now saying they will not invest in companies that are not committed to be, carbon neutral, for instance, by X date. So I have a sense that there's some momentum around doing things. Too little, too late. I don't think we're going to know until we get there, I'm afraid, is the answer to that.
But a lot of the surveys of the consuming public indicate that a majority are not prepared to pay more for products prepared in an environmentally friendly way or through systems where labor in Bangladesh is paid proper wages. I've got to say the nice example Shirley-Anne gave are very, very hopeful, but they remain a minority. Every survey shows a large number of people say, no, we're not prepared to pay more. So if it's got to be led not by the consumer, it's brands and retail. And as Shirley-Anne says, if they're going to disadvantage themselves competitively by imposing the higher cost of environmentally and socially friendly products, then they're likely to lose market share unless that is applied as a system on a pretty global basis.
I mean, there's someone saying there in the chat, how can we help with these challenges?
Yeah.
It can feel overwhelming. I think from my own personal perspective, things like washing less, consuming less, certainly, using garments over it, sharing, if you're mums, if you're grandmums, sharing garments, passing things on so they're not.
You know what you think about, you're thinking about that, you think.
Sorry, say that again? sorry, I thought somebody was saying something there. But I think and on a broader front, again, speaking personally as well, I try to look for brands and retailers that I think are trying to do a better job. You know, Marks and Spencer started down this route a long time ago, for instance, and my have they taken flack over the years for either what they do or their results, because so often it's led by the shareholders and the share price. But I think if one, as a consumer, takes the responsibility to look at what the brands you buy from are doing, read about them, ask questions of them, you know, put notes on their social media if you don't like what they're doing, etc., etc. We do have some consumer power. Lobby in any way you can, you know, things also in the political sphere for dealing with textile waste. We're not even dealing with plastic waste properly in the UK, and way behind some of our European cousins when it comes to some of the stuff. So, you know, pick your battle to fight, I think, but just inform yourself as much as you possibly can.
But in terms of the discussion we're having here, it's very much being conducted in a sophisticated Western consuming market. The rest of the world, which is consuming far less textiles than we are, actually doesn't give a damn about that. They simply want more clothing. They want a better lifestyle expressed in a better range of textile goods. And it's very, very hard to say to those people, you know, no, you can't have it because that's not good for the planet. They're saying, there you are with your 23 kilos per capita in Europe, 36 in USA. We're here with 6. Who are you to tell us to cut back on textile consumption because it's bad for the planet? So we can argue for solutions in a sophisticated US and European production and consumer environment. But it's the same thing as global warming. There we are sitting on an existing lifestyle, telling other people they can't have that. So I think we have to have systems that are fair in a global context and rules that we can reasonably expect to be applied on a global basis. Otherwise, it's all a non-starter.
Okay.
Great. Any more questions? If not, I'd just like to thank David and Shirley-Anne again for a fascinating talk and giving us lots to think about. Thank you.
Thanks.
Rachel, do you have any announcements to make or any comments at the end?
Well, just to reiterate, yes, fabulous, and you'll have seen in the comments. Thanks for your erudition and covering so much so clearly. That's fabulous.
At a clip.
Yeah, superb. It's so strange, isn't it, in this part of the world where wool was so huge. You know, it wasn't just your granny in the corner. You know, it was a massive industry here, but to be so dwarfed now. But I'll no doubt carry on the conversation with you about what the contributions can be in this part of the world to these challenges that you've raised. But that's for another conversation. And a conversation that we hope to have in future. Well, we hoped to have a session on the 14th of June, and now our speaker can't make it, I'm afraid, not least because he's suffering with the effects of long COVID. And so I would like to ask if there's anybody here this evening who has ideas for a hot topic for June. There isn't time to go into this now, but if you'd like to drop a line to me, you know how to find me, then please do let me know if A, you've got a topic in mind, and B, if you know of somebody who's a likely presenter on that topic. So I'd be delighted to hear from anybody on that. So we do have other talks lined up for the rest of the year, and it's just that we haven't been clear about whether they're going to be real, hybrid, or still online. So that's why the things aren't all up on the website yet. But do rest assured that we have got the programme in hand. And indeed, we're planning very much for next year as well. And Janet Douglas, the chair of the committee, and I are meeting tomorrow. So do get your thoughts in, and we'll look forward to seeing as many of you as possible next time. And I think that's all for now.
Thank you very much indeed. Thank you.
Thank you, everybody, and take care and see you next time, hopefully. All the best.
Bye-bye now.
Bye-bye.
Oh, and by the way, yes, the recording will eventually be on the website under this. So it'll be a past event, and you find all the videos for the past events eventually come up in the relevant bit of the website. Okay.
Right.
Thank you.
Good.
Bye-bye now.
Stop recording.